Alright, and welcome to Solving Systems with Substitution. Here in example 1, I want you to notice how this is different from our previous problem. The first thing I want you to notice is that we actually have a variable by itself. Right here, all we have is just an x by itself. So rather than this being in y equals mx plus b in slope-intercept form, just note that a variable is by itself. The second thing to note is that over here we actually have 2x plus 6y. When the x's and the y's are both on the same side, what we actually call that is standard form. So how in the world do we do this? Well, what I want you to do is where we have x equals, or the variable by itself, I want to write the word is above the equal sign. I think this is very helpful. What we're saying is that x is negative 2y plus 6. So, as I read this second equation from left to right, and I say something like this, I say, okay, what we have is 2, and because it's x is, we're going to replace this with a very large parentheses. So we have 2x plus 6y is equal to 20. And if I ask you, okay, well, what is x? You would say x is negative 2y plus 6. So in place of x, we're going to put negative 2y plus 6. And notice at this point the only variable you see is a y. So since there's only one type of variable, we can now solve for that y. Okay, so let's go ahead and distribute. And we see 2 times negative 2y is going to be negative 4y. And 2 times 6 will give us plus 12. And then of course from here, let me just switch colors back, we have this plus 6y equals 20. Now the big mistake that I always see students make is when you combine these y's, you try to switch the sign. Notice that we are all on the left side of the equal sign, and since we're on the same side, we just combine them like normal. So negative 4y plus 6y, well, negative 4 plus 6 is really negative 2y. Okay, so we have negative 2y plus 12 equals 20. Now at this point, we continue to solve for y. And let's see, we know we get rid of our addition or subtraction first. In this case, it's addition. So we'll do minus 12, and this goes ahead and gives us negative 2y is equal to 20 minus 12 is 8. From here, we can divide both sides by negative 2, and we get y equals negative 4. Now, remember from our previous problem, solving for your single variable, solving that's one of the steps, but we actually need to solve for the other variable. So let's go ahead and take this original equation here, where it says x is, or x equals, negative 2y plus 6. Let's write it as such. X equals negative 2, big parentheses in place of y, plus 6. And so if I ask you, okay, well, what is y? Remember, we can say that y is negative 4. And from here, we can solve for x. Negative 2 times negative 4 is going to be positive 8 plus 6. And so we know x is equal to 14. Now, at this point, we write our final solution, or the place where these two lines are intersecting, as our x value, 14, comma, our y value, negative 4. And there we have our answer. Go ahead and pause this, and let's go on to our second example. Okay, for example 2, it's my hope that this will actually be a trickier problem. So notice, even though this top equation is what we would consider y equals mx plus b, this second equation is still in standard form. Okay, so they're both not in slope-intercept form, and this indicates we should actually use substitution. Alright, the best way to think about substitution is to use it when one of the equations, and only one of the equations, has a variable by itself. So let's go ahead and consider this. Y is 3x minus 7. And so because it says y is, we know that we're going to replace that y value. Okay, so let's write this as 2x minus 5y equals 9. Now, why did we write this is sign? Because we're saying that y is 3x minus 7. So if I ask you what is y, you would say, oh yeah, y is 3x minus 7. And from this point forward, we can solve for x. We drop this 2x. Here we have negative 5 times 3x which will be negative 15x. We have a negative times a negative, which is a positive, and 5 times 7 is 35. And of course, this all equals 9. Now from here, let's go ahead and combine our like terms. Remember, we're on the same side of the equal sign, so we don't change the sign. 2x minus 15x will actually give us negative 13x plus 35 is equal to 9. And from here, in order to get x by itself, let's do minus 35 minus 35. And in this case, we'll get negative 13x is equal to 9 minus 35 will actually give us negative 26. And that's kind of unfortunate. I was hoping that this would be a trickier problem, but it's not. Okay, in order to get rid of this negative 13, we divide both sides by negative 13. And I tell you that it's not a tricky problem because negative 26 divided by negative 13 is positive 2. Okay, so we have x is positive 2. Now remember, that is not the final solution. Let's go take this equation where y is by itself. Let's write y equals 3x minus 7. And if I were to ask you, well, what is x? You would say x is 2. And so I'll plug in that 2. Now from here, we can say, okay, well, you know what? 3 times 2 is 6 minus 7. And 6 minus 7 is negative 1. And this brings us to our final solution, which has our x value of 2, comma, our y value of negative 1. And we can say that these two lines are going to intersect at the point 2, comma, negative 1. Now, I hope that you'll stick around because I want to show you a special case for example 3. It'll be very, very quick and very, very easy. All right, so let's go to that. Okay, here we are in example 3, and this is our special case. So we have y equals 2x minus 6, and we notice that in this one, it is the only equation or function where our variable is by itself. And here we have this second one in standard form because the x and the y are on the left. So let's go ahead and use substitution, and let's write our word is. So we can say y is 2x minus 6. So if it's saying y is, we know we're going to replace our y value. So let's go ahead and rewrite this as negative 4x plus 2y is equal to negative 12. And if I ask you, well, what is y? We'd say y is 2x minus 6. Okay, and at this point, we can solve for x. We drop our negative 4x, and 2 times 2x will be positive 4x, and 2 times negative 6 is negative 12, which equals negative 12. Now, in this case, what is negative 4x plus 4x? Well, that's 0. It's a 0 pair. It cancels. And we're left with negative 12 equals negative 12, which is what we call a true statement. If I were to ask you, hey, does negative 12 equal negative 12? You'd say, yeah, that's true. And what this implies is that we have infinite solutions. Now, why in the world do we get infinite solutions? Well, the thing is that these two lines that we started out with are actually the same line. Okay, so I want you to understand, like, what if we had an xy axis and I graphed y equals 2x minus 6. So here's negative 6. And I just went up 1, 2, to the right 1. And I went up 1, 2, and to the right 1. So on and so forth. And I had, whoa, that's weird. And I had this line, okay? Well, this line right here, if I were to solve for the y value and get this into slope-intercept form, it would actually be the exact same line. And so if you have two lines on top of each other, or the exact same line, well, and I were to ask you, okay, where do they intersect? Do they intersect right there? Yeah. Do they intersect right there? Yeah. Do they intersect right there? Yeah. One more time, do they intersect right there? Yeah. And so there are infinitely many points where these two lines intersect, so there must be infinite solutions. All right, thank you, and I'll catch y'all in our third video.